So as you're wrapping up this week, just a little more gas law practices for you. Again, the biggest thing is being able to take a look at a problem and determine which law to use. So that's where we're going to start with this video. So I would say jot down for today's video, have a piece of paper, calculator, periodic table, and piece of paper, of course, and jot down your ideas. So 1 through 6, see what you would come up with. Great time to pause the video and then come right on back and we'll see how you did. All right, so for number 1, constant volume. So T and P are changing. That's Gay-Lussac's law. He used toilet paper on his maypole. How about number 2? P and V, hopefully you were thinking Boyle's law. Boys play video games is my memory device for that one. How about number 3? The combined gas law, because we often can't keep pressure or temperature or volume constant. They are often likely to change, and so that combined gas law. How about Charles's law for number 4? T and V, Charlie Brown is a TV show, my memory device for that one. How about number 5? Avogadro's law, yes, that number of particles, 6.02 times 10 to the 23rd. Particles is a mole. How about number 6? Yes, the ideal gas law. And of course, don't forget R. You did calculate R in our last lab based on your own experimental data. And then, of course, you're going to need to be able to do some calculations. Once you've determined which law to use, you got to be able to look at the data and pick out what you need, convert it to the correct units, and then put it into the gas law equation. So let's take a look at this problem. This would be a great time to pause the video. I'll give you another opportunity to pause the video after determining the correct law and the needed information. All right, so hopefully you started taking a look at all this information that was given. Hopefully I've got all my circles in the right spots. There we go. And then starting to look at, okay, so what is this? Is this a pressure? Is this a temperature? Is this a volume? So I can, or is this a number of moles? So I can figure out which law to use. So hopefully you figured that 22.5 is a temperature, and I'm simply going to need to convert that to Kelvin by adding 273. Hopefully you thought, okay, 754 millimeters, that's a pressure, but I'm probably going to need to convert that. I'm looking for volume. I don't know what it is. I've got the volume of the balloon at one time, and there's another pressure. My last temperature, hopefully you could see that was a negative 33, so I'm going to need to convert that to kelvins by adding 273. And then I've got my combined gas law. And so now you're going to want to put all of that information into that combined gas law to figure out the missing volume. But first, be sure you converted that other pressure to atmospheres. Great time now to pause the video and see if you have all the correct information. Can you put it into the equation correctly and calculate the volume? Oh, hopefully I've got mine calculated correctly. So on one side of the equation, I've got those values. On the other side, I've got those. And then to solve for V2, I simply kind of cleaned it up a little bit, keeping my units along for the ride. And then finally, I calculated V2 and reduced it to 2 significant figures. Notice that as I'm doing this, my atmospheres, kelvins, are going to cancel out. So I had to divide both sides by 0.00038333 atmospheres, kelvins to get V2. Hopefully you did well on that one. Again, I always suggest you already know each of the gas laws. Just combine them into one. And then if you don't need temperature, you just leave it out. All right, so which law? Pressure, volume, and temperature. Hopefully you're thinking the combined gas law. Volume's held constant. What happens to temperature when pressure increases? Hopefully you were thinking that Gay-Lussac's law and the temperature is also going to increase. How about what happens to volume when temperature is held constant and pressure increases? Hopefully you were thinking volume's going to decrease. That's Boyle's law. All right, how about this one? What equation would you use? Hopefully you were thinking Dalton's law of partial pressures. Again, what is an ideal gas? An ideal gas is one that has virtually no intermolecular forces. Those particles of the gas, they're very tiny. There should be small spaces in between them, and there's virtually no attraction between those particles. They're compressible, almost to zero volume, and they exert pressure by bumping into the sides of their container. And there, of course, is our ideal gas law. Here are some practice problems for you. Again, a great time to pause the video and see if you can figure out the pressure. Hopefully you used our ideal gas law, converting those grams to moles, putting everything in. Now, I chose to put everything in and then we'll solve for P. I could have right off the top said, no, I'm just going to go ahead and divide both sides by V, so that I could have my P by itself. And that is your choice, whatever you want to do. Hopefully you figured out that P is 5.2 atmospheres. Here's another one for you. I think I've got 4 or 5 here for you to practice with. So see if you can calculate this volume. So hopefully you use Charles's law there. And I come up with a volume of 0.3087. Now I'm going to have to take that to 2 significant figures, so 0.31. Notice that your units that cancel out. There we go. And round it to the correct number of significant figures. All right, here's another one. Great time to pause the video and see if you can figure out how many moles. And so for this one, because all you've got is liters, you've got to use that 22.4 liters of a gas is 1 mole. And so then you can get your moles very simply and round to 3 significant figures. How about this one? Great time to pause the video as you calculate that volume. Hopefully you were thinking TV, Charles's law. And hopefully you came up with a volume of 3.3. Here's another one. See if you can figure out the pressure. So we've got volume, we've got pressure. So hopefully you were thinking Boyle's law, boys play video games. And hopefully you substituted those in and then simply figured out, the pressure. Rounded to 3 significant figures. Here's the last one I have for you. And it looks like you're asked for the pressure in a container that has oxygen, hydrogen, and helium. First, of course, you've got to get all your pressures in the same units. So it may be a good time to go back, just simply look at the problem, and then see if you can get the correct answer. So hopefully you came up with 9.47 atmospheres. I believe I have one more for you because this stoichiometry is not going away. So take a moment and look at this. See what you would do. Hopefully you were thinking, well, first I've got to write a balanced equation, and you are exactly right. And now I know I've got a certain amount of salt. I can figure out how much HCl is produced. So see if you can go ahead and do this problem. All right, so again, look at what you're starting with. You've got to convert your grams to moles. And again, if you take a look, what's going to diagonally drop or cancel out here, your grams of NaCl is going to be gone. And then your balanced equation tells you that 2 moles of HCl react with 2 moles of NaCl. And those moles of NaCl then are going to cancel out. And so if you go straight across the top, 10.2 times 1 times 2 divided by 58.5 times 2, you should get, and I had to stop there simply because I was out of room, you should get 0.174 moles of HCl, and then use 22.4 liters is a mole. Notice your moles of HCl are going to cancel out here, and you've got 3.9, and I actually could have left that at 3 significant figures, so it'd be 3.91. I saw it in my calculator to round to 3 significant figures. So this is just a little thing to keep you going. I hope this helps you as you're working through the gas laws.